Here's a simple series circuit consisting of a 12 volt battery connected to two resistors, 2 ohms and 4 ohms in series. Remember, it's in series because the electricity is nowhere else to go. You can see those coulombs of charge flowing around that circuit and they haven't got any other branches to go to. So it's a series circuit. Now this circuit is also called a voltage divider circuit, and we can see why in a minute. We can see that the 2 ohm and the 4 ohm resistor, when they're connected in series, is going to give us a total resistance of 6 ohms. If we have a battery of 12 volts, then you can do Ohm's law, and that's going to give us a current of 2 amps. Now let's check out the voltage across each resistor. Across the 2 ohm resistor, the voltage, or the potential difference, is going to be 4 volts. Which means when the electricity passes through that resistor, each coulomb of charge is going to lose 4 joules. Now if we look at the potential difference across the 4 ohm resistor, we can guess that it's going to be 8 volts because it's going to be double the resistance, therefore it's going to soak up double the energy per coulomb. So let's check it out. And you can see the voltage is going to be 8 volts. Now what we've done is we've taken the 12 volt battery, and if we go across each of these resistors, we actually can have a share of the voltage. Now the bigger the resistor will have, the bigger the share of the voltage, or the bigger the potential difference dropped across it. Check that again. We go to here and we have a potential difference of 4 volts. Go to here and we have a potential difference of 8 volts. As we can see there. So we have 4 volts plus 8 volts is going to give us a 12 volts. So what's really happened is that these two resistors have divided up the voltage of the battery in cell. So how can we do that theoretically in circuit theory? Well, let's do it. Here's our series circuit. Now let's apply some circuit theory to see how we can divide up the 12 volts across each of these two resistors. Well, we know right away that the total resistance in this circuit is equal to the sum of the two resistors, R1 plus R2. That's going to give us 2 ohms plus 4 ohms. So the total resistance is going to be 6 ohms. If we know the total resistance, we can find the current flowing in the circuit. Remember, it's a series circuit. So from Ohm's law, the current I equals V divided by R, the total resistance, which is equal to 12 divided by 6. So we're going to have a total current of 2 amps flowing in that circuit. Now if we know the current flowing through a resistor and know its value, we can work out the potential difference across it. Below the resistor in question, we just put down our symbols V, I and R. And we know that the current flowing in the circuit is going to be 2 amps. And we know the resistance of the circuit is going to be 2 ohms. So therefore V equal to IR is going to be quite simply 2 times 2, which is going to give us 4 volts. So across this resistor, we're going to have 4 volts. What about the second resistor? Well, we can do V equals IR again below it. We know the current is going to be 2 amps. We know the resistance is going to be 4 ohms, and therefore V equals IR is going to give us 2 times 4 is going to give us 8. So V equals I times R is going to give us 2 times 4, which equals 8 volts. So we know the voltage across the 4 ohm resistor is going to be 8 volts. And that means that the 12 volts up here have been split up to give you a 4 volts and 8 volts. So that circuit is really what we call a voltage divider circuit. Now it's not usually written that way. Sometimes it's written in this sort of format, the electronic format, but it's still the same. You can see we have the 12 volt battery, you can see we have the 2 ohms and the 4 ohms, and it's connected in series, and the current is going to flow around the circuit like that. Once again, we can work out the current flowing in the circuit. The current I is V divided by the total resistance, and the total resistance is 6 ohms and the voltage is 12 volts, so it's 12 volts divided by 6 ohms is going to give us 2 amps again. And all we have to do is go beside each resistor and write down our values, V I and R, and we know the current is 2 amps. We worked it out. We know the resistance is going to give us 2 ohms, and therefore we know that V equals IR. 2 times 2 is going to give us 4 volts. So across this resistor here, we're going to have 4 volts. And we do the same with this one here. But before we do it, we can use our voltage divider rule. If we know we're going to have 4 volts across this resistor here, then across this resistor is going to be 8 volts, which makes up the 12 volts from the supply. So we're looking for an answer of 8 volts. V equals IR, the current is 2 amps, the resistance is 4 ohms, and therefore V equals 2 times 4 is going to give us 8 volts, just what we expected. So no matter which form the circuit appears in, either in the electronic form or in the form which we usually do in circuit theory, we treat it as a voltage divider circuit, and we can use our circuit theory to work out the potential differences across each resistor.